All right, guys, welcome back to the next episode where we are going to talk through the audio switches. Guys, this is where things are going to get interesting. I'm warning you now. Let's make some room here. Let's see if we can get these switches over here so we can see. First thing we're going to do, we're going to tackle our resistance ladder. Excuse me. We're going to tackle our resistance ladder for the 2012. So let's first take a look at our harness. We're going to try to do this as quick as we can. So looking at this, we have the steering wheel controls. No. 12 volt reference. That's our number 6. And that would be, okay, 1, 2, 3, 4, 5, 6. And then our second one, which is our steering wheel control signal, I believe that's number 7. So let's drop that in number 7. And then let's take a look here at the diagram for audio. So here's our audio side. We have our number blah, 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 coming all the way in through here. And it comes in through number 6. So that is accurate. And then it goes across and it goes out through number 7. So this should be correct. So now we want to make sure that all of our resistance ladder is accurate. So let's go ahead. Let's take a look at this and let's start pressing buttons. So our resting is 0. That makes sense because our ladder doesn't have any resting resistance. Okay. Let's start at the bottom. So let's do volume up. We should see our resistor, our multimeter here show at least roughly 1.2. Perfect. Volume down, 1.5. Perfect. We're going to do arrow source up, 1.9. We got 2.4. Okay, now we want to press this like a button. 3.0. 2 more. We have push to talk, which is going to give us 3.83. And finally, we have our hang up, mute, and call, 5.31. So we know our resistance ladder here is perfectly accurate as it's written. So let's now move on to the 2016. 2016. The first thing you need to notice is that on the 2016 is not just one switch. Remember, I'm going to set this, I'm actually going to remove this. This is our cruise control. I haven't taken it out since we all were looking at this together. Okay, let's get that out of the way. So now, the thing you need to recognize is you have actually 3 sets of switches for the 2016. You have your original switches here, which mine is taken apart. But you have your favorite up, favorite down. You have your volume up, volume down. I'm going to keep this simple for you guys and just say it does not use a resistance ladder at all. The 2016 Plus does not use it at all. It actually uses a microcontroller on here to actually do all of the processing. So if you notice here, here is our right switch. Okay, let me get this out of the way for you guys. Here is our right switch. Here is basically the microcontroller that is doing the logic, which actually lives on the switch itself. Then we have our favorites buttons, and we have our volume buttons. Now, the tough part about this is that this all uses something called the LIN bus system. Okay, I'm not going to get too much into the details of it, but long story short, instead of having all these extra wires, you know, this and blah, 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 you got this resistance ladder, how are you going to manage all the wires between this? They've simplified everything to one microcontroller, which then sends a digital signal to your instrument cluster. Okay? That instrument cluster then sends the signal over to your radio, probably your audio control module. So, why is this important? It's important because there is no resistance ladder. Notice, there's none. Absolutely none. What's actually happening is The system is utilizing a chip. Now, I'll turn this over. You're not going to be able to see it that well from there, but I'll try to point it out. Right here, this black chip is where all the magic happens. So all of your buttons come in through varying pins on here that then send one signal out through this bottom leg here of the switch to your instrument cluster. And that's what this is right here. Okay? So your fuse comes in, it sends it in, your whole microcontroller absorbs the brains of everything. You know, some of this information is grounded, and then boom, it sends the signal over your instrument cluster. What does this mean for us? Okay? For most people, they would stop here because they'd say, you know what? There's no way to convert this. There's no way. To that, I say, no way. I will find a way. And that's what we're going to do. But for those of you guys who want to see it, what I'm going to share with you is actually a quick, let's say, preview of what I'm talking about. Because I think until you guys actually see it, it's not that easy to comprehend what I'm referring to when I say this microcontroller, this integrated chip. So I did some deep diving, right? I looked at the chip itself. I looked at some zoomed in versions. The company that actually sells it is called, I believe it's Melexis, and it's an 80104D chip. And you can actually find the data sheet. You know, I found the data sheet. I read into it. I learned how it works. And it's how I kind of concluded that there really is no way other than interpreting the digital signal and going from there. So here's the circuit boards of that switch. And there's a lot going on here, but I will simplify it for you that this is your Melexis chip. Your red signal is the power signal that comes into the system, powers your Melexis chip and allows it to function. Then each time you ground one, what the Melexis chip does is it checks each one of these constantly and says, is it being grounded? Is it being grounded? Is it being grounded? You know, for instance, it's checking this signal right here, which goes through here and pops out on this side. And it says, when I press the right button, is it going to the ground plane? If it does, boom, this pin right here sends out a digital signal through here. It comes out here and it goes into pin 2, which is our LIN bus, and it sends that signal off to your instrument cluster. Okay? So, and so on and so forth, right? Each one of these represents a different one, with the exception of this line right here, which actually represents the power going to your LEDs. Okay, so the signal is constantly trying to send this out. This over here is a transistor, which is not going to allow that signal to pass through unless it sees a voltage being applied. Obviously, when your car is turned on and your body control module sends this signal, okay, allow that to flow and allow it to light up all of your things. And not just here, but also notice this is to each of it. It goes to my right button LED. It goes to my down button LED. It goes to my source button LED in the middle. Up here, we have our up LED, our left LED, our talk to speak LED, and our hang up LED. The yellow is the LEDs that actually exit this switch and go and power your volume up and down, your favorite up and down, and your LED in your cruise control. So I want you guys to interpret that and think about that. In the old steering wheel, your LEDs were powered directly from your body control module with all these wires. What they've opted to do here is they have all of that information go through this Melexis chip, right? And then that sends the signal out to the rest of the system. Now, I'll add one more piece to this is the Melexis chip is a smart chip. It doesn't just turn on when you turn the car on, okay? It needs to be woken up with a special signal. And what is that special signal? It's a signal the instrument cluster sends. So we have now that we're here where we are, we have a couple different problems we're going to need to get over. We're going to need to figure out, do we directly or indirectly power our LEDs and disconnect them from this Malexis chip? So that's the first one. But secondly, how do we actually work through these buttons? And even if we wanted to use the Malexis chip, how do we simulate a 2016 instrument cluster in the car? We can't swap the instrument cluster, as far as I know, in the 2012. I don't even think it fits physically. And I'm sure nobody wants to buy an instrument cluster from a 2016 plus Camaro. If I said Mustang before, I meant Camaro. And drop it into the trunk, or have it ride shotgun on the passenger seat. Nobody wants that. So we're going to have to figure out how to trick this chip into waking up and actually operating, providing digital signals that we can then interpret. But then we need to figure out, what do we even do with them, right? So I want to end here for this episode. I think in the next one we're really gonna tackle this one head on. But I think it was really important for you guys to understand that we got three primary, let's say, functions we need to tackle and get out of the way. The tap to shift, which is great. We don't have any issues with that. We can leave it as is. The cruise control, which is, I would say, a medium to slightly bigger problem, where typically we would just have to change the resistance ladder, but unfortunately we don't have a toggle switch on the 2016 like we do on the 2012. And then we have this nightmare of an audio situation that we're going to have to figure out. So I hope you've learned something. I hope I'll catch you in the next one. And I hope I'll see you around. See ya.